Welcome back to the OpenAI Associate Developer course. In this lesson, we will walk through the code needed to set up and run a solution using the OpenAI Speech-to-Text API to transcribe an audio file. We will read the speech from an audio file and convert it into text. This coding exercise will allow you to better understand how this STT API can be used in common use cases, such as transcription services, voice command interfaces, and real-time captioning. With that, let's go ahead and jump into the code. To begin, we will start with only the outline of the basic OpenAI setup code in our main.ts file and an empty configurations object in our defs file. Since the main file will require very few changes compared to the text-to-speech code we've already seen, we'll start there. In our main.ts file, you'll notice the basic setup code along with an empty main function. This is code we've seen many times before. Next, we will add the OpenAI Transcription API call. This call is OpenAI Audio Transcriptions Create, and we pass in our OpenAI Configurations object as the only parameter. Note, you may see errors as we have not yet set up the configuration object in our defs file, which we'll do shortly. The speech-to-text API call returns an OpenAI Audio Transcriptions transcription object, which we will use to log the AI-generated audio transcription to the console. For this, we will use the text property of the returned transcription object to retrieve the AI-generated transcription and log the transcribed text to the console. And that's all we need in our main file. Let's now move to our defs file and set up our configuration object. First, in our defs file, notice the read audio from file arrow function. This is the same functionality we've seen in previous code examples to read images from a file. Again, this function takes in the name of the file and returns an FS readable stream, which is of type uploadable. Here, we need this function to read in the audio file from disk, since, as with the Images API, here too we need the actual audio file contents and not a URL. This file reading code should look familiar to you, so let's save some room and collapse the file reading function. Okay, now we're ready to start adding in the variables we'll use for our speech-to-text configuration properties. First, we'll add a variable for the model property and name it STT_model. We'll set our model to the only model which supports the speech-to-text functionality, which is Whisper-1. Now set the model property to our STT_model variable. And now we come to our prompt variable, which we'll name STT_prompt. The prompt here is used more as an informational hint to the AI rather than a command giving the AI direct instructions. Here, our prompt is used to help the AI better understand the audio content. For our example, since dragons can have some strange names and live in strange places, the AI may have a difficult time understanding the audio content. Therefore, we'll provide a prompt to help the AI understand the context of the audio file and to know that it may encounter some strange names and imaginary places. Go ahead and now set the prompt properties value to the STT_prompt variable. Next, we'll add a string variable for the audio file name. We'll set this to the name of our audio file, Dragon Story. If you're not using the sample code, be sure to replace this with the name of your audio file. Now, set the file properties value returned by the audio file read function. This is where you'll pass in the audio file you want to transcribe. And that's all we need to make our bare minimum speech-to-text API call. Go ahead and compile and run your code, and you should see the AI-generated transcription of the audio file logged to the console. So far, we have the two required properties set up, the model and the file, and an optional STT property, the prompt. When you compiled and ran your code, you saw the AI's generated transcription of the audio file. However, the transcription was pretty basic and little more than just the text of the audio but no metadata. Now, we'll add the configuration properties which not only impact the creativity of the transcription, but its format as well. However, before moving forward, there's a change we're going to make in our main file. Here, we are simply going to change our log statement to log the STT response object as a JSON object rather than just the text. It will make sense why we're doing this in a moment. Once that's done, recompile and run your code, and you should notice virtually no change compared to the output you've seen in your previous runs. Let's now go back to our defs file. The first property we'll add is the language property. In our case, since our audio file is in English, we'll set the property's value to EN for English. Remember, this property is an ISO 639-1 formatted language string, and the language property needs to match the language of the audio. Next, we'll add the temperature property. Here, we'll set the temperature to a near-middle value to have the AI give us back our dragon story without encouraging much deviation from the true audio content. We'll set our temperature to 0.7 for an initial value. Later, depending on the results we get back from the AI, we can adjust this value as necessary. After setting these two additional properties, if we compile and run our code, it's likely we'll see a nearly identical transcription as before. Here, you're encouraged to adjust these properties to see the impact each has on your results. We are now going to move towards adding in configuration properties, which will significantly change the output of the AI-generated transcription. While these properties will not impact the transcription's accuracy, they will impact the format and amount of the returned content. The first property we'll add is the response format property. The response format property in OpenAI's speech-to-text API determines the format in which the transcription results are returned. Here, we will use a union variable and name it response_format. The options this variable can be set to are JSON, text, SRT, verbose JSON, or VTT, and we will initially set the variable to text, and will then set the response format property's value to the response format variable. Now, go ahead and compile and run your code again. You should notice no change in the transcription the AI returns. The reason for this is that we have set our response format to text, which is the response format's default value the AI uses. To see a change in the AI's transcription output, update the response format's value from text to verbose JSON. Now, recompile and run your code. You should see a substantial difference to the output logged to your console. Don't worry about the specifics of this output. In the next lesson, we'll be going over everything about it. We are now going to add the timestamp granularities property. For this property, we'll need to set a union variable, which may look strange at initial glance. We declare this union variable to only be able to take the value of word or segment. This is no different than any other union variable. However, we have placed open and close parentheses around these values. This is because this is actually an array union variable, and each index in the array must be either word or segment. For now, we'll set this array to only contain one element and set the value to segment. Go ahead and recompile and run your code. You should notice the JSON output is nearly the same as before. When we look at our output, after changing the response format variable to verbose JSON, we saw a huge difference in our output. However, when we set the timestamp granularities, we saw virtually the same output as what setting the response format gave us. The reason for this is that we set our timestamp granularities to segment, and this is the default value the AI uses, and so you saw no change. In order to see a change in the output, go ahead and set the timestamp granularities to word, and then recompile and run your code. Now, even though you may not fully understand the differences you're seeing, you should nonetheless notice a change in the output. And finally, set the timestamp granularities to contain both segment and word together. This is where the array portion of the variable can be seen more clearly. Once you've added both the segment and word entries, recompile and run your code. Again, you should see a change in the output. In summary, we saw the transcription create call will return an OpenAI audio transcriptions transcription object. Additionally, we saw how to set up and configure each of the OpenAI Transcription API configuration properties. These included the model, prompt, file, language, temperature, response format, and the timestamp granularities. We also saw how significantly the AI's response content changes based on the values we give the configuration properties. This completes the lesson on configuring and executing the OpenAI Transcription API. In the next lesson, we will look at the output produced by the OpenAI transcription calls, more specifically, the response format and the timestamp granularity output. we will look at the output in much more detail. Stay tuned, and let's continue enhancing our AI-powered applications together.